Hello and welcome back to another episode of Math with Sohn. Today we're going to be solving quadratic equations, which also means we could be finding the x-intercepts if this was a y-equals equation, all right, which will be very important when we're graphing these later on. So the first few are already factored for us, so that's beautiful. Because if it's factored for you, all you have to do is set your factors individually equal to 0 to solve, which in many cases will mean that you just change the sign of it. Okay, so here if you set 2x squared equal to 0, you divide by 2. You get 0. You get x squared equals 0. You square root both sides. If you square root the 0, make sure it doesn't matter in this case, but you should, anytime you're square rooting when you're solving, include a plus or minus. So x equals plus or minus square root of 0, which means that x equals 0, positive and negative 0. And if x minus 3 is equal to 0, you would add 3 over, and you get x equals 3. Okay? So that is true. And notice how this 3 just turned into a positive 3. If it is in parentheses and you're factored, you can almost always just change the sign. Okay, so if we were to do it the correct way, you're supposed to set it equal to 0. However, that takes a lot of writing to really realize that just x equals negative 2, positive 5. It's not going to equal 3. You're going to have to change the sign and then divide by 5. So it will equal 3 over 5, which would happen if we set it equal to 0. We'd add 3, and you get 5x equals 3. And then you would divide by 5. And if you divide by 5, you get 3 over 5 the same way. So change the sign and divide by that number, and you can get your answer a lot quicker. Okay? So be careful, because that change the sign thing works for this one, 2. But it's not going to work for this one because, again, you have a number in front. That's a negative 1 in front. So if we change the sign here, you'd have negative 3 divided by negative 1, which is positive 3. Again, you're more than welcome to set it equal to 0 to get your positive 3 that way, though. Okay? The next few we're going to be doing are just going to be factoring. In order to factor to solve or find the x-intercepts, you need to either have it equal to y or equal to 0. In this case, for the first few, we might have it equal to 0. If you have 3 terms, you're looking for what multiplies to the last number, but adds up to the middle one. So what multiplies to 8, but adds to 2, would be not 1 and 8. It's going to be 2 and 4. So it's going to be x minus 4 and x plus 2 that would add to negative 2 and multiply to the negative 8. Now, because this is equal to 0 still, you can just change the signs of these as long as there's no funny business going on, and there isn't any, so x is just going to equal 4 and negative 2. All right? The next one, number 5, is our first problem that is not equal to 0. If it's not equal to 0, you have to set it equal to 0. So we're going to subtract that 5x over, not 5x, 5 over, and now we can factor. What multiplies to 5 but adds to 4? Well, 1 and 5 are the only things that multiply to 5, so we got x minus 5 and x plus 1. Let's make sure our signs are right. Does negative 5 plus 1 add to negative 4? Yeah. Does it multiply to negative 5? Yes. So here, our answers for x, if we set them equal to 0, would be x equals 5 and negative 1. All right, number 6. This one, you have 2 options. You can factor it, yes. You can also recognize that you only have an x squared. If you only have an x squared, you are welcome to divide by 2 and get x squared is equal to 8. And then, if you square root it, you would have plus or minus the square root of 8. Do not forget the plus or minus, which it looks like I almost did, so I'm going to rewrite it. X equals plus or minus the square root of 8. Okay, so that is one option for how to do with those problems, because believe it or not, this is also not factorable. If you wanted to factor it, it would end up being like, it'd be weird. It'd be 2 in front, and then you'd have x plus the square root of 8 and x minus the square root of 8, which would be really weird. Okay, and not a normal factor problem. Let's see the next one. Here, we can divide everything by 2, so why not? Let's divide everything by 2. Because we're dividing everything by 2 and there's an equal sign, we don't have to factor it out. You can just divide. You can factor it out if you want to, but you don't have to, because it divides off with the equal sign there. Everything kind of just divides by 2. Now we have to set it equal to 0. We're going to subtract the 12 over, equal to 0. What multiplies to 12 but adds to 4? So the things that multiply to 12 are 1 and 12, 2 and 6, 2 and 6 is the winner. That's the one that we'll add to negative 4. We're going to have an x minus 6 and an x plus 2 equals 0. If you had just factored out the 2, there'd be a 2 sitting out there, okay? So if you had just factored out the 2, that would just be sitting there. We didn't. And by the way, that 2 does not have an x. Because it doesn't have an x, it doesn't count as a solution. Here, our two solutions are going to be 6, change the sign, and negative 2, changing the sign. All right. Next one. Here we have a 9x squared minus 9x equals 10. Let's set it equal to 0. That's going to be 9x squared minus 9x minus 10 equals 0. You can't divide everything by 9 or 3 or anything, so we actually have to multiply the 9 and the 10 together. These two, 9 times negative 10, to get 90. What multiplies to 90 but adds to negative 9? Well, we got 9 and 10. That's not it. We got 2 and 45. That's not it. Let's see. We got 3 and 30. We got 4 and I think 15. No, 4 and 20. I don't think 4 works. What's 90 divided by 5? I need a calculator. 90 divided by 5 is 18. 5 and 18, that's not it. 90 divided by 6 is 15. I think that's the one. 6 and 15. Found it. So 6 and 15 in some way, shape, or form can add to 9. By the way, perseverance. We started with 2, then went to 3, then went to 4, then went to 5, then we went to 6. It's okay to take a while. We got 6 and 15. In order for it to add to a negative 9, it would be a negative 15 and a positive 6. Because we had a 9 in the beginning, we have to divide both of these by 9. If we were factoring, we would have to simplify these and then move the number in front. We're not factoring this time. We're just solving. So all we have to do is change the signs of both of these, 15 over 9 and negative 6 over 9, which turns into 15 over 9. We do simplify fractions. We divide them both by 3. We get 5 over 3 and 2 over 3 when we divide the other one by both by 3. Ta-da. Number 9. This one. You could do this whole 4 times 0 idea because the last term is 0. So if you do that and if you're completely stuck, you could do that. And I'm going to prove to you that you can, even though it's not the best method. The best method is greatest common factor. 4 times 0 is 0. What multiplies to 0 but adds to negative 28? That would be 0 and negative 28. So this would be x minus 28 and x plus 0, so to speak. It's weird. And then we would have to divide them both by 4. Okay? If you do that, you end up with a x minus 7 and the 0 doesn't divide by 4, so we're going to move that over here to a 4x. That would have been the quickest way to do it, by the way, because what can you divide both of these by? You can divide them both by a 4x. If we did that in the beginning, you would be able to divide 4 by 4 to get 1x, and then set 28 by 4 to get minus 7. Either way you do it is okay. You do have to set both of them equal to 0 to get your solutions. I'm doing that this time because 4x is a factor, and when you set that equal to 0, you get x equals 0. And the other one, when you set the x minus 7 equal to 0, you get the regular, change the sign, x equals 7. All right, we just got a few more, and then we're going to be done for the day. This next one is, if you recognize it, only has an x squared, so you can solve it by square rooting. It is also a perfect square factor problem, so I'm going to do that real quick. They're both square rootable, so this is going to be 3x minus 4 and 3x plus 4. Because they're both square rootable and there's that minus sign in between, because of that, you can set them both equal to 0 and solve. Or you can recognize that you have to change the sign and then divide by 3. We're going to add 4 and divide by 3. You get 4 over 3 and negative 4 over 3. Okay? Well, what if you didn't want to do it by factoring? You could also add the 16 over and then divide by 9. And then you get 16 over 9. And a lot of people freak out with that because once you square root it, you get plus or minus the square root of 16 over 9, which ends up being 4 over 3 anyways, with a plus or minus. So both ways end up getting the same exact answer. It's okay, whichever method you get, but you do have to square at the top and the bottom of the fraction. This next one, I'm betting we are going to have to factor. It's an x to the fourth. That doesn't change anything. We're going to subtract the 12 over. We're going to get x to the fourth minus 7x squared minus 12 equals 0. The reason that this is still factorable is because it's a 4, then a 2, then no x's. So what multiplies to 12 but adds to 7? Well, that's going to be a 4 and a 3. So this is going to be x squared minus 4 and x squared minus 3 equals 0. What do we do with our factors to solve? We can set our factors individually equal to 0 to solve. So if we set x squared minus 4 equal to 0, you get x squared equals 4, which means x equals plus or minus the square root of 4, which means x equals plus or minus 2. And if we do the same thing with the 3, you get x squared equals 3, and that means that x equals plus or minus the square root of 3, and we get our 4 answers. So you may be asking, how does this one have 2 and that one have 4? Well, if it's an x to the fourth, it should have 4 answers. If it's an x squared, you should have 2. Should being the key word. It's not always a guarantee. All right, last one, number 12. Here we got negative 9x squared minus 3 is equal to 6x. I am going to not move the 6x. I'm actually going to move the 9x squared because I really don't like having a negative x squared. It's possible, but it makes the problem a lot harder, and I always recommend factoring out a negative or getting rid of it or dividing by it if you can. So here I'm going to add the 9x squared. That will accomplish the same task, and add the 3. Add 9x squared, add the 3, add 9x squared, add the 3. That cancels. We get 0 equals 9x squared with a positive 6x and a positive 3. What else can we do? They all can divide by 3. So you can factor out that 3 if you want to. You can also just divide everything by 3. Both ways work. You get 3x squared, 2x, and a 1. Now we can start factoring. We have to multiply this 3 times 1. You get 3. What multiplies to 3 but adds to a positive 2? Nothing. So I am going to adapt the problem slightly. I'm going to change this to a plus 3. That way when we subtract the 3, it becomes a negative 3. And then it would actually factor. Okay, so I'm changing the problem slightly. If that were a negative 3 when we subtract it over, this would be a negative 3, and this would be a negative 1. Now we can recognize that 3 and 1 can subtract together to make positive 2. So this is going to be an x plus 3 and an x minus 1. We do not forget that this number right here, we have to divide each of them by. So this is going to be a x plus 1 and a 3x minus 1. But again, we're solving here, so we set our factors individually equal to 0. This 3 does not equal 0. It's not an answer because it doesn't have an x. This one, when we set it equal to 0, we're going to get negative 1. This one, when we set it equal to 0, 3x minus 1 equal to 0. You could also look right here. You see that x minus 1/3? You're going to get a 1/3. So you get x equals negative 1 and 1/3 for your 2 answers there. Okay, that's going to do it for this one. Until next time, everybody, stay positive, and I will see y'all later. Bye.